Hello, I'm presenter Pham Tram Anh. Every year, tons of agriculture byproducts are discarded, and one of them is the clausena indica seeds. Yet, hidden inside its overlooked seeds are powerful bioactive compounds with antioxidant and anti-inflammatory effects. In a world facing rising rates of chronic inflammation and oxidative stress-related disease, turning waste into wellness is not just a choice, it is a necessity.
Clausena indica seeds are an inexpensive, readily available byproduct, often discarded during food processing, yet the rich bioactive content offers anti-inflammatory and antioxidant potential, helping reduce agricultural waste and support sustainable natural pharmaceutical development.
We, students from School Imperial High School, aim to extract pharmaceutical bioactives from clausena indica seeds, a food byproduct.
Our study contained two main objectives. Firstly, to isolate and identify the chemical constituents from clausena indica seed extract. Secondly, to evaluate their bioactivities, focusing on antioxidant and anti-inflammatory properties.
First of all, we summarized the procedure using two diagrams, one for the extraction of the clausena indica seeds and one for the isolating poor compounds of the extract.
I'm using 5 types of solvents. The first one is N-hexane, the second one is dichloromethane, the third one is ethylene acetate, the fourth one is methanol, and the last one is water. Despite its low yield, N-hexane was chosen for isolation due to its simple composition and resistant content, while water was good for its weak bioactivity and complexity.
The ethylene acetate extract showed the weak antioxidant activities, while the others had the negligible effect. All extract inhibited NO productions, with the dichloromethanes being the most potent, with the IC15 at 1.82 microgram per milliliter.
The clausena indica seeds yield bioactive fractions with strong anti-inflammatory effects. Dichloromethane was the most potential, while only ethylene acetate showed weak antioxidant activity. These findings suggest pharmaceutical potential, especially from compounds like myristogens.
TOC analysis revealed that N-hexane had a single clear spot, indicating low impurity. In contrast, dichloromethane has several spots, and ethylene acetate show a complex overlapping pattern. Therefore, N-hexane was the most suitable for isolation.
The N-hexane extract was separated by column chromatography, yielding 6 fractions from F1 to F6. F1 to 0.4 grams was the most abundant, and further purification produced crude extract 2 grams, the major compound for analysis. To determine the structure of myristicin, we first used HNMR to identify key protein types. I then applied CNMR and depth to classify carbon atoms.
The hydrogen NMR spectrum of the EHM showed the 2 aromatic protons, a 6.3 and 6.8 ppm, indicating an aromatic ring. A single sharp at 3.87 ppm confirmed the presence of the methyl C group, while the 3 aphanic protons at 5 to 6.2 ppm were characteristic of the conjunctive double bond.
The CNMR spectrum of EHM revealed 11 carbons signal, including 6 aromatic carbons. The department confirmed this substance with missing peaks, suggesting quaternary carbons. This data indicate a phenylpropanone structure with aromatic, methyl C, and propanone chain.
HMBC analysis confirmed the methoxy group at C3, sigma H 3.88 to C3, and the aniline group at C1, sigma H 3.28 to mutable carbons near C1. HSQC correlations further support the structural assignments.
The EHM was identified as a myristicin, a bioactive compound from clausena indica seed. It showed the pharmaceutical potentials as an anti-cancer agent by inducing the apoptosis and the down-regulating DNA repair genes, highlighting its values in drug development.
From 600 grams of clausena indica seeds, we obtained 4 different extracts. EHME displayed the only weak antioxidant activity, while the remaining 3 showed no significant effects. EHMD showed strong anti-inflammatory effects.
Also, we isolate 2 grams of pure myristicin from EHMH, a compound with anti-inflammatory and anti-cancer potential.
So here are our development directions. First is semi-synthesized pharmaceutical agents from myristicin. Second is further isolate poor compounds from remaining fractions and evaluate the bioactivities.
And the scientists from School Imperial High School have succeeded in the experiment of researching the clausena indica seeds. Thank you for listening.